I am going to discuss about the frame management in data link layer. Hi, I am Dr. G. Karthikeya, Head and Associate Professor, Department of Computer Science Aided of V.V. Vane Perumal College for Women, Virudhunagar. What is a computer network? The computer network is a group of autonomous computers connected to each other to share resources and information. What are the resources that can be shared in a computer network? It may be a database, it may be a file, it may be a printer, or it may be a hard disk drive. Any hardware and software resources can be shared in a computer network. To control the computer network, we have two different standards worldwide. The software models ISO OSI reference model and TCP/IP reference model are used worldwide to control the network. The OSI reference model stands for International Standards Organization Open System Interconnection. This model is arranged in the form of layered architecture, and there are 7 layers. These layers are implemented as software modules so that if one module is to be modified, then the coding corresponding to that module itself will be changed without affecting other modules. Now we will see what are the different layers that are present in the ISO OSI model. We have a phrase, people do need to send packets away, to remember the order in which the layers are arranged. In the bottom, we have the physical layer, then we have data link layer, network layer, transport layer, session layer, presentation layer, and the topmost layer is the application layer. But today we are going to deal about the frame management by the data link layer. The data link layer is the second layer from the bottom of the ISO OSI reference model. It is getting the service from the physical layer and it provides the service to the network layer. It is getting a set of bits from the physical layer and converts them into a frame. These frames are to be provided to the network layer. Apart from the frame management, different services are offered to the network layer by the data link layer. In addition, it does the functions of error control and flow control. Now let's see how the frame is prepared by the data link layer. From the network layer, in the receiver side, we will be passing the information to the transport layer. But in the sender side, the network layer will be providing packets to the data link layer. The packet will be put inside the payload of the frame, which is the data unit of the data link layer. Before the payload, we will be placing the header, and after the payload, we place the trailer. What are the contents of the frame header? The frame header usually contains the source and the destination system addresses. In addition, we will be having some of the control bytes. The payload field contains the data that is received from the network layer. The trailer contains the information for error correction and error detection. Now let's see the three different kinds of fields which are present in the header. The first one is the kind which distinguishes the frame. Either the frame may be a data frame, or it may be a acknowledgement frame, or it may be a control frame. This information is placed in the kind field. Then we have the sequence number for the frame if it is a data frame. If it is an acknowledgement frame, we have the acknowledgement frame for which we are going to send the acknowledgement. Suppose I have to send acknowledgement for the fifth frame, then this ACK sequence number will be 5, saying that we are sending the acknowledgement for the fifth frame. When you are sending a frame, how does the receiver understand? This is the starting of the frame, this is the ending of the frame. So you must insert some form of boundary in the frame to differentiate it from the previous and the next frames. So it is achieved by different methods by the data link layer. One method is including how many number of bytes are present in the frame. So that represents the byte count. Including the count, if you are going to send 4 bytes, the byte count will be 5. So starting from 5, 1, 2, 3, 4 bytes will be representing one frame. On the receiver side, the receiver will be retrieving this byte count and it understands that 5 consecutive bytes are forming this frame. So one example is given here. Here we have different frames starting with different byte counts. But what may be the disadvantage of this byte count method? Suppose instead of 5, the byte count is changed to a 7 by flipping only one bit. The receiver will be assuming that 7 bytes are forming this frame. So if that is the case, it will be taking 2 bytes from the next frame. So the receiver will not get the correct byte count for a frame. Even though we have the checksum as an incorrect one, and we are asking the sender to send the frame again, we cannot get a synchronization because the receiver cannot inform from which frame it has to resend. The sender has to resend. That cannot be correctly predicted by the receiver. So we go for other methods as byte stuffing and bit stuffing. So in the byte stuffing, one byte will be added as a flag marking the beginning and the end of the frame. Usually we may be having the flag byte as a hexadecimal 7E 0111110 will be the flag byte. So this will be placed in the starting and the end of the frame. So flag byte will be followed by the header, and then you have the payload, then trailer will be followed again by the flag. But suppose inside the payload we have the flag byte, what will happen? the receiver understands that if you are having 2 consecutive flag bytes, it is the starting of one frame and the end of the previous frame. But if this is the case, inside the data itself, a flag byte is appearing. If that is the case, then it will be preceded. That flag byte will be preceded by one escape byte. So, in the receiver side, if the escape is followed by a flag, the escape character will be removed by the receiver and it understands the data correctly. But if the escape itself is appearing inside the data, then again one more escape character will be placed before that escape character. So, when in the receiver side, if it is receiving 2 consecutive escape characters, then one escape character will be stripped off and it will be considered as a data escape character. So, this will be of somewhat advantageous compared to the previous one, but the disadvantages, we can operate only on bytes, that is 8-bit bytes. So, we go for one more method called as the bit stuffing. Here also we are including the same delimiter, starting the frame with the 7E, ending the frame with 7E. But suppose inside the data we have consecutive ones. What will happen? It may be treated as the end of the frame. So, to avoid that, once you have 5 consecutive ones, inside the data a 0 bit will be added. So, after 5 consecutive ones, if the bit stream sees a 0, then it will be removed or stripped off in the receiver side, understanding only the 7E as the marking of the beginning and the end of the frame. One more method can also be used. So, here we have the example of flag bit with bit stuffing. We have the original data, we have the stuffed data, and then on the receiver side how it is correctly interpreted. So, that also is shown in this example. But suppose here you have a change in the bit. Say after the 5 consecutive ones we have a 0. If there is a flipping of that 0 due to the transmission error, then there may be a problem. So, to avoid that, we may go for one more method using the physical layer coding violations. Usually, the physical layer will be using the transition from the 0 state to the 1 state or 1 state to the 0 state to mark the data bit. So, we do not have a consecutive 0 0 or consecutive 1 1 in the data. This concept can be used to mark the beginning of the frame and the end of the frame. Either you use a 0 0 or you use the 1 1 for marking the beginning and the end of the frame. Suppose the physical layer is using 4B 5B code. This code may be used for preparing the bit stream. If that is the case, the 4B 5B code will not allow 3 consecutive zeros. So, in the data, if you have 3 consecutive zeros, then that may be used to mark the beginning and the end of the frame. Say, if 3 consecutive zeros are appearing in a number, that number may be used for representing the beginning byte and the ending byte. So far we have seen different methods of frame management, that is how the frame is prepared and sent to the other side. For the marking of beginning and end of the frame, we have different methods as byte count, flag byte with byte stuffing, flag byte with bit stuffing, and you have the physical layer code violations. Using any one of the method, the frame can be sent to the other side successfully. Better it will be using the bit stuffing and the physical layer code violations because of the restrictions in the byte count and the flag byte with byte stuffing methods. So these are the functions of the data link layer. It prepares a frame successfully, attaching the marking the beginning and the end of the frame as either a physical layer code violation or intermediate zeros are included by bit stuffing. Thank you for hearing.